All right, so today we're working on graphing radical functions. If you're in class, the sub should have given you this worksheet, and if you're at home, you will find this worksheet attached to the same announcement where I posted a link to this video. Now, before we get started with our worksheet, I want us to go over here and think back to some of the types of functions that we've graphed before, because I want to talk to you guys about something that we've never really discussed, because it's something we haven't really had to think about for other types of functions. But a main component to a function is that for every input you get only one output in a function. If you have an input in a function and you get more than one output, it is no longer a function. That is not considered a function. So the definition of a function is for every input, you get one and only one output. So what that is essentially saying is that for every x value that you plug in, you should only get one y value. So if I were to plug in 0 into a function, or 1, or any number into a function for x, you should get only one y value. You should not get more than one y value. So let's talk about a linear function first. So with a linear function, we have y equals x, right? And when we have a linear function, say that we were to plug in 0 into this function, we get y equals 0, right? So here at the origin, if we were to plug in 1 into this function, we would get an output of 1. If we were to plug in 2 as our input into this function, we would get an output of 2, right? So our points would be right here. And then say we were to plug in -1, we would get an output of -1. If we were to plug in -2, we would get an output of -2 as well, right? So our linear function looks like this, right? For every input that we plug into this function, every x value, we get exactly one output. Now let's look back to a quadratic function. So same thing here. Say that we were to plug in, I'm going to extend this line a little bit. But say that we were to plug in 0 into this function. So you would get y equals 0 squared. 0 squared is just 0. So right here at the origin, right? This graph is not perfect, but we'll pretend that it is. If I were to plug in -1 into this function, I would get y equals -1 squared, which is going to be +1, right? So when x is 1, y is also 1. If I were to, or sorry, that one goes over here. If I were to plug in +1 into this function, so if +1 is my input, my output is also going to be +1, right? Because 1 squared is still 1. So that would go over here. If I were to plug in +2 into this function, I get y equals 2 squared, which is 4, right? So it'd be somewhere around here. And if I were to plug in -2 into this function, I would get also +4, because -2 is -2 squared is +4. So that would be graphed right around here. So you see, again, for every input that we plugged in, we got exactly one output. And your outputs could repeat. You see how we got 4, but you can have, your outputs can repeat. What cannot repeat is your input. So you can't have, when you plug in, say that when you plug in 2, you can't have 4 and -4 as your output. You can only have one output. All right, so let's go back to our worksheet. And we're going to think back to that in just a second. But first, I'm going to give you guys the parent function of a square root function. So the parent function of a square root function is going to be equal to it's going to be equal to f of x is equal to the square root of x, right? And now I want to show you guys how to do this using the xy table. So I want to show you guys how to graph this function using the xy table, and then I'll show you guys how to do it on your graphing calculator. Now, this is where we have to think about one output gets exactly, or one input gets exactly one output. Say that you were to plug in, so when we plug in 0 into this function, let's start off with that because that's easy. The square root of 0 is 0, right? It's only one output. 0 can't be positive or negative. But let's say that you were to plug in 2 into this function, or let's start with 1. Square root of 1, we know that when we do the square root of something, we get plus or minus 1, right? So that means that if we plugged in 1 into this function, we would get plus or minus 1. But we can't do that. That makes it be no longer a function, right? Because we, in that scenario right there, we got 2 outputs for 1 input. And we can't have that. So for that reason, when you do a square root function or a cube root function, any radical function, when you do those, you are going to have to use the principal the principal root, which is saying the positive root. So if I'm doing the square root of 1 in a function, since I can only have one output for every input, I'm going to use the principal root, which is the positive root. So if I were to plug in the square root of 1, I would only be using positive 1. Now that would change if, for example, let's say you get the negative square root of x. That would be the negative root that you would be using there. But for these purposes and for radical functions that are just parent functions, you are going to be using the principal root or the positive root that you get from each function or from each input. All right, so now that we know that, so if I plug in 1 into this function, the square root of 1 is 1. We're just using the principal root, so that is 1, right? And one thing to think about as well, you can't plug in negative numbers into a square root function, right? You can only plug in positive numbers. So we know that we can't do negative 1, we can't do anything below 0, right? So our starting point is 0. When x is 1, our output is 1. And think of the perfect squares. This is where the perfect squares are also going to help you. So we have 1, 4, 9, 16, 25, and so on, right? So now instead of going to 2, because the square root of 2 is not a whole number, we're going to skip to number 4, right? So when we plug in 4 into this function, the square root of 4, if we're only taking this principal root, is 2, right? And then if we go to 9, when we plug in 9 into this function, we get 3, right? So now we can graph those points. So we start at 0, 0. And then when we're graphing the next points, when x is 1, y is 1. So, and then when x is 4, y is 2. So we'd be right here. When x is 9, y is 3. So then our graph would look like this. And it would go on forever, right? Because you can continue to plug in positive roots or positive inputs into this function, right? 1 squared, 4 squared, 9 squared, 16, 25, and so on. And you continue on forever. So now let's talk about some of the descriptions of this function. So for the endpoint refers to where our function ends. In this part of the function, it's going to continue on forever, so it has no endpoint. However, we have an endpoint right here because we can't plug in negative values into this function, so our input would be right here at 0, 0. And this is, you're only going to have an endpoint for even root functions. So square roots, fourth roots, sixth roots, eighth roots, all those types of functions, those will have endpoints because you can't plug in negative numbers. However, in a odd root number or function, you're not going to have an endpoint because you can plug in negative numbers into odd root functions. So like the cube root, you can take the cube root of a negative number, the fifth root, the seventh root, all those odd roots you could take of a negative number. Now the domain, so the domain refers to what x values we can plug into our function. So we can only plug in 0 and above, right? We can't plug in anything below 0. So our domain here would be x is greater than or equal to 0, right? Because we know that we can't plug in -1 or anything below that. into our function. Now for our range refers to our y values. So since we can only get one output for every input, and we're only going to be using the principal root, which means the positive roots, that means we're only going to have positive y values. So our range is also going to be y is greater than or equal to 0, because you can't have -1, you can't have -4, or sorry, -2, -3 as your outputs. So all our outputs are going to be positive. And if you wanted to graph this on your graphing calculator, you would go to your calculator, you click y equals. You're going to click second and the x squared button right here, and it brings up the radical, right? And then you're just going to type in x and you click graph, and there's the graph. Mine looks a little warped because it's, really stretched out. So if you want to look at the XY table, you click second and graph, and you see everything below 0 says error because you can't take the square root of a negative number. And then when x is 0, y is 0. When x is 1, 1, 4, 2, 9, 3, 16, 4, right? So you would go to the perfect squares because you know that you're going to get a whole number that you can graph on a graph. All right. So next we have the cube root parent function. So with the cube root parent function, you are going to write out f of x is equal to the cube root of x. That is the parent function of a cube root function. With cube root functions, you don't have to worry about one input for every output, or sorry, one output for every input, because anyway, in a cube root function, with everything you plug in, you're only going to get one output anyway, right? So we're going to make our XY table. All right. So again, it's going to be very helpful to write out the perfect cubes, right? So the perfect cubes, we have 1, 8, 27, and so that's 2 squared, 3 squared, or sorry, 2 cubed, 3 cubed, 4 cubed is going to be 64, and so on, right? So we're not even going to be able to graph those, but they can also be negative, right? You can take the negative cube root of a function. So let's go ahead and get started here. So we're going to start with 0, right? Because 0 is always the easiest input to start with. So if you plug in 0 into this function, you're going to get f of x is equal to the cube root of 0. So the cube root of 0 is going to be 0, right? So we can go ahead and plug that point in. And then let's take the cube root of 1. The cube root of 1 is going to be 1, right? So that point's right here. And let me actually make these a little bit smaller. And then if you were to plug in -1 in here, the cube root of -1 is -1, right? Because -1 times -1 times -1 is going to be -1. So we know the cube root of -1 is -1. Let's graph that point. Next, if the next perfect cube is -8, right? We know that the cube root of negative or positive 8 is going to be, so if we plug in 8 into this function, positive 8, we're going to get positive 2 as our output, right? So when x is 8, y is 2. So that point's going to be over here. And then if we plug in -8 into this function, we get an output of -2, right? When x is 8, y is -2. So that is where our point is. We can't, the next perfect cube is 27. we're not going to be able to graph that, so we're going to go ahead and just connect our dots. So our graph is going to look something like this. So that is what the graph of this cube root parent function looks like. Now we're going to talk about some of the characteristics of it. So the turning point. The turning point is right here at 0, 0, right? You guys see that? Because this at 0, 0, if you go to the right, our values start to be positive, and it goes, our outputs are positive and our inputs are positive as well. And then before 0, 0, our outputs are negative and so are our inputs, right? So this is the turning point right here. This is where the graph turns. So our turning point is at 0, 0. The domain refers to our x values. Since this is a cube root function, and we can take the cube root of positive and negative numbers, this is going to be there's going to be no domain restrictions because you can plug in any number in here, right? So the domain is all real numbers. And then the range refers to our y values. And this segment of the graph is continuing to increase. So we're going to continue to get higher and higher positive y values. And then this segment of the graph is going towards negative infinity. So we're going to continue to get lower and lower negative numbers, right? So the range will also be all real numbers. Well, if you go on and plug in all numbers into infinity, you would eventually get all real ranges, right? So hope that made sense for these two parent functions. Next, we're going to talk about the transformations of square root and cube root functions. So if you look here, we have f of x is equal to a times the nth root of x minus h plus k. So you guys should recognize h and k. H and k refers to our translations either horizontal or vertical, right? And a refers to a dilation in our graph, right? So over here, we know that h refers to the horizontal shift. And then if it's positive, it's going to shift left, right? If you have a positive h value, it's going to shift the graph left. And if you have a negative h value, it's going to shift the graph right. Next, k is the vertical translation or vertical shift, right? So if k is positive, we're going to get a shift up. If k is negative, we're going to get a shift down, right? You guys should remember this. And then the end point or the turning point is always going to be hk. So if you have your function in this format, you'll know where the turning point is. So you'll know where the turning point is, and you'll also know where the graph, if the graph shifts left or right and up or down. And then if a is negative, the function is reflected across the x-axis, right? That stays the same. And then if a is greater than 1, meaning it's, any number greater than 1, so 2, 3, and so on, it represents a vertical stretch. And then if a is greater than 0 but less than 1, meaning it's a fraction, then it represents a vertical compression. So the stretch means that that our points get further away from the x-axis, and the compression means that our points get closer to the x-axis, right? So now that we know this, you guys should be able to do this, so you can go ahead and pause the video and do numbers 1, 2, 3, and 4, and then continue, because I'm going to go over the answers now. So here are we have h, right? And it's negative. So if you look back to our notes here, we know that when h is negative, it's going to be a shift right. And then it's going to be by 7 units, right? Next we have our k here. And we know that when k is positive, it's going to be a shift up. And it's going to be by 2 units, right? And then next for number 2. So we have a is greater than 1. So this is a vertical stretch by 4. We have no h value, so the graph isn't going to shift horizontally, but we have a k value and it's negative, so it's going to be a shift down by 1. Then for number 3, we have negative a, right? So this is going to be a reflection across the x-axis. We have an h and it's positive, so that is going to be a shift left by 3. Next we have, and that's it, we don't have a k, right? Next we have f of x is equal to 1/2 square root of x minus 2 minus 6. So this one has everything, right? Except for the reflection. So this represents a vertical compression, right? So if a is greater than 0 but less than 1, it's a vertical compression. So we have a vertical compression by 1/2. We have a negative h value, which represents a shift right by 2. And then we have a negative k value, which represents a shift, shift down by 2. All right, so hope this all made sense. Next, on the next page, we're going to be, so we can talk about this. So here it says, we're going to be writing a function. So this says the square root parent function. So let's go ahead and get started with that. We know that this is the square root parent function, x. And so you can write a square root, and you can write an x. And then it says the square root parent function is reflected across the x-axis. So that means that it is negative, right? And then it is shifted 7 units left. So 7 units left would represent an h value. And since it's shifting left, it is positive. So x plus 7. And then 1 unit down, which is k, so minus 1. And it tells us to write an equation that represents this function. So f of x is equal to negative square root of x plus 7 minus 1. Number 6 says a cube root function has a turning point located at negative 2, 3. Write an equation that could represent this function. So if you remember, hk is the turning point. So that means that this is f of x is equal to, and it's a cube root function. F of x is equal to the cube root of x plus 2 plus 3. And you're probably wondering why I made this positive. So let's go back to our first page. And now this says that the endpoint or the turning point is h, right? It's positive h. Over here in the function, it's negative h, right? So they're opposites. So if this is positive, this has to be negative in the function, right? If like the point, if the point h is positive, in the function it's negative, and that means that if in the function it's negative, or sorry, in the point it's negative, in the function it would be positive. So over here, the point was negative, so that means that this has to be positive. So that's why it's x plus 2. Next, it tells us to graph each radical function and identify the key characteristics. So we have the square root of x plus 5. So we already know what the parent function looks like, right? We graphed that earlier. This is what the parent function of a square root function looks like. So this is the same thing except that it is shifting up 5 units, right? So in the parent function, our starting point would be right here, right? But it's shifting up 5 units, so it's 1, 2, 3, 4, 5. So this time our starting point is right here, right? And then we could do our XY table. So when x is 0, our output is 5, right? And this is also our turning point, or our endpoint in this case, right? So we already know what our endpoint is. Our endpoint is 0, 5, right? This is where the graph ends, since this is a square root function, and we can't have negative x values. And we also know that the domain, we can also, from this point right here, we can already tell what the domain is going to be and the range. Since we can't have negative values, that means that our domain is going to be x is greater than or equal to 0. Because again, we can only plug in 0 and greater numbers than that, right? And in our range, because we know that our graph is going to look something like this, we know that our range is going to be y is greater than or equal to 5, right? Because we're not going to get any values below this, this point right here. So let's go ahead and graph this function. So again, we're going to pick the perfect squares. So we know that the perfect squares, I'm going to write them over here. So we have 1, 4, 9, 16. We're only going to go up to 9, right? Because we're not going to be able to graph 16 on the x-axis here. So if I were to plug in 1, and let me adjust this because I can't get anything lower than 0. So if I plug in 1 into this function, the square root of 1 is 1, and then plus 5 is going to be 6, right? So that point is going to be right here at 1, 6. If I plug in the square root of 4, so the square root of 4 is 2, and then plus 5 is 7. So that point would be at 1, 2, 3, 4. Right here. If I were to plug in the next perfect square is 9. If I were to plug in 9 into this function, the square root of 9 is 3, plus 5 is 8. So then it would be right here at 9, 8. Which is over here. So then the graph of our function would look like this. And you can go ahead and graph it in your graphing calculator. So the way you would do this, you'd go y equals. You would type in second and x squared, which gives you the radical. You type in x, then you're going to use the directional buttons to click right, and then you're going to write plus 5. When you click graph, it looks like that, right? It shifts up 5 units from the parent function. If you look at your table, when x is 0, y is 5, 1, 6, 4, 7, 9, 8, which is the same points that we graphed here, right? Next, if we talk about the end behaviors, so as x approaches infinity, let me do that. So as x approaches infinity, meaning our x values are getting greater, our y values are also getting greater, right? So that means that our output, or f of x, is also approaching infinity. Then next would be as x approaches 0, right? Can't approach negative infinity because we don't have any values. We don't have any values that are less than 0, so x is going to have to approach 0 in the other direction. So as x approaches 0, our y values are going from, you see how the graph is going like this, our y values are increasing, but if you're going in the opposite direction, our y values are decreasing, right? And they're decreasing towards where the y value is 5, because it can't approach negative infinity. It also is not going to approach 0 because you can never have a y value of 0. So as x approaches 0, our output, or f of x, is approaching 5. It's approaching this point right here at 0, 5. So our y value there is 5, and that's what it's approaching. And then the increasing interval is, we only have an increasing interval, right? We don't have a decreasing interval. And our increasing interval is from 0 to infinity, right? This 0 and this infinity is referring to our x values, right? So our graph is increasing from x value 0 all the way into infinity. And then, like I said, we don't have a decreasing interval because it's only an increasing interval. Next, we have f of x is equal to, excuse me, f of x is equal to the square root of x minus 1 minus 4. So this is going to be a shift from the parent function at, it's going to be a shift right by 1 and a shift down by 4. So we can start at our starting point, right? Let's draw our xy table, and you can plug in 0, right? So that's going to be our starting point. So when x is 0, you get 0 minus 1, which is negative 1. So you actually can't do that. So 0 is not going to be your starting point this time. Our starting point is going to be at x equals 1, right? Because you have, when x is 1, you have 1 minus 1, which is the square root of 0, which is 0, minus 4. So y is negative 4. So you can't plug in 0 into this function because you would get the square root of 0 minus 1, which is the square root of negative 1, and you can't do that. So that's why we can't plug in 0. So your starting point would be what makes your radicand 0, right, which is 1. And then you get 0 minus 4 is negative 4. So our starting point would be at 1, negative 4. Our starting point is here. Next, you want to think about, so the perfect squares, right? So we have 1, we have 4, we have 9, we have 16, and so on. But we've only been going up to 9, so we're going to just stop right there. But you have to think about it. You have to get plus 1, right? Plus 1 because you're subtracting 1. So if you were to plug in 4 in here, you would get 4 minus 1, which is equal to 3. The square root of 3 is not a perfect square. So you have to start at 1 plus the perfect squares, right? So if I were to plug in 5 into this function, I would get 5 minus 1, which is equal to 4. The square root of 4, right? So then I could do that. So the next value that you want to plug in here is not actually 4, but 5. Because then you would get the square root of 5 minus 1 minus 4. Square root of 5 minus 1 is the square root of 4, which is 2, minus 4, which is negative 2. And again, if you're having a hard time identifying the values that you should plug in, you can go straight to your graphing calculator. You're going to type in the function. The function is y equals the square, gotta go to y equals the square root of x minus 1 minus 4. This is what the graph is going to look like. You see it shifted below the x-axis and to the right of the y-axis. And you're going to click second and graph, and here's your points. So when x is 1, output is negative 4. We have that already, right? When x is 2, you get negative 3. Oh, yeah, you could have plugged in 2, right? When x is 2, your output is negative 3. When x is 5, your output is negative 2, which we already had that one, right? x is 5, when x is 5, y is negative 2. Then when x is 10, y is negative 1. So let's go ahead and graph those points. So this is what our graph is going to look like. And we can't graph any other points below that. So now let's talk about the domain and the range. So the domain refers to our x values that we can plug in, right? The smallest x value that we're able to plug in is 1, right? So that means that our domain is going to be x is greater than or equal to 1. Before it was 0, right? But this time we can't plug in 0. If you plug in 0 into this function, your equation would be undefined because you'd get a negative radicand. So our domain is x is greater than or equal to 1. And then our range refers to our y values that we can plug in, right? So the lowest value, y value that we can get is negative 4. So our range is y is greater than or equal to negative 4. Next, we have our endpoint or our turning point, which is hk, right? So the opposite of this, which is 1. And then this, which is negative 4. So 1, negative 4. And it's this point right here, right, where our graph ends. Next, for the end behavior, as the same thing as x approaches infinity, our output is also approaching infinity. Then next, as x approaches, this time it's approaching 1, right? So it's moving in this direction, and it can't go below x value of 1. So as x approaches 1, our y values, they're decreasing, right? And they're decreasing towards negative 4 y value. And then our increasing interval, right here, it starts at where, and it's referring to our x values, right? So the starting point of our increasing interval is here at where x is 1, and it's increasing all the way into infinity. And we don't have a decreasing interval here in this function. Next, for number 9, again, we have a square root function. This time we have a vertical stretch by 3, and we have a shift left by 1, right? So let's go ahead and draw our xy table. So you can start plugging in values at negative 1, right? You can plug in negative 1 for x now, right? Because negative 1 plus 1 would give you 0, and you can take the square root of 0. So that is your starting point, negative 1. So negative 1, it makes this, if you were to plug in negative 1, this would turn 3 times the square root of negative 1 plus 1. And this becomes 3 times the square root of 0. Square root of 0 is 0, right? So then 3 times 0 is 0. So I hope that doesn't confuse you guys, because I know that we said that we can't plug in negative values when we were working on the parent function of a square root function. Well, the reason that we couldn't plug in negative values there is because it would leave our radicand 0, right? So if you have the square root of x, if you plug in any negative number, your radicand is going to be negative. You can't take the square root of a negative number. However, here, since you have plus 1, you can plug in only one negative number, which is negative 1, because it would make our radicand 0. So you can plug in numbers that will make your radicand 0 or greater than that when you're doing a square root function. Right? That's why I was able to plug in negative 1. I don't want you guys to get confused by that, because I when we were doing the square root function, parent function of a square root function, I told you can't plug in negative x values. However, here, that x value, that negative x value made my radicand 0. So That's why. But you can't plug in -2 now because -2 plus 1 is -1. And then you would have a negative radicand, which does not work. So our starting point is at -1, 0. Next, think of this of the perfect square. So 149. And you want to pick a number before this time, right? Because if you were to plug in 4 in here, 4 plus 1 is 5. And you can't take the square root of 5, right? Well, I mean, you can, but it's not a whole number. So I want to start 1 before this, right? So if I plug in 3 now, 3 plus 1 becomes the square root of 4, right? So let's go ahead and plug in 3. Oh, and you can also plug in 0, right? Because if you plug in 0, you get 0 plus 1, which becomes the square root of 1, and you can't take the square root of 1, right? The square root of 1 is 1. So when you plug in 0 into this function, you get 1. So the point would be right here. Next, you can plug in 3, which becomes, oh, and I forgot about the vertical stretch, right? So this is 3 times the square root of 0 plus 1, which becomes 3 times the square root of 1. Square root of 1 is 1, so this becomes 3 times 1, which is 3. So my output would actually be 3 here, not 1. And that's what represents the vertical stretch by 3. So my point would actually be right here. Next, you would want to plug in 3, right? Because then you would have 3 times the square root of 3 plus 1, which becomes 3 times the square root of 4. Square root of 4 is 2, so this is 3 times 2, which is 6. So when your x value is 3, your output is 6. So this looks a lot different from the other graphs that we've done because now we have a vertical stretch. Next is the next perfect square is 9. So you want to pick 1 before it, right? So this becomes 3 times the square root of 8 plus 1, right? So we're plugging 8 in this time. This becomes 3 times the square root of 9. Square root of 9 is 3. 3 times 3 is equal to 9, right? So then your point would be at 8, 9. So that point is right here. All right, so now that we've graphed this function, we can talk about its characteristics. So the domain refers to our x values that we can plug in. So the lowest x value that we're able to plug in is -1. So all our x values have to be -1 or greater, which means that our domain is x is greater than or equal to -1. Now our range, the lowest y value that we have is at 0. So that means that all our outputs or y values are going to be 0 or greater, which means our range is y is greater than or equal to 0. And then the end point, turning point, is this point right here, which is -1, 0. Right? HK, -1. So it's the opposite of +1, right? And there's no k value, which means it's 0. And then our end behaviors as x approaches infinity, our output is also approaching infinity, right? As our x values increase, our y values are increasing as well. And then this time the end behavior is going this way, going towards like this part of the graph. So it's approaching -1, right? You can't approach anything less than that. So as x approaches -1, our output or our y values is approaching 0, right? And then for the increasing interval, this whole thing, right? So the interval or the graph is increasing from where our x value is -1 all the way to infinity, right? So our increasing interval is at -1 to infinity. And we don't have a decreasing interval. So the next page, I will be posting a video for that tomorrow. It's getting close to the start of class time, so I want to be able to upload this video to YouTube for you guys and then post the link. So I'll post this later on today if you guys want to work ahead on this third page.